Hey, section 8.2, and let's get going. So we have confidence intervals for a population mean, where the standard deviation, population standard deviation is unknown. So we're going to describe the properties of the student's t-distribution. We're going to construct confidence intervals for a population mean when the population standard deviation is unknown. Describing the properties of a student's t's distribution. So when we're constructing a confidence interval where we know the population standard deviation, little sigma, the confidence interval is x bar plus or minus z of alpha over 2 times the standard deviation divided by the square root of the sample. The critical value is c alpha over z alpha over 2 because the quantity x bar minus mu over the standard deviation times the square root of the sample has a normal distribution. It is rare that we would know the population standard deviation while needing to estimate the value of mu. In practice, it's more common that it is unknown, and when we don't know the value of the population standard deviation, we may replace it with the sample standard deviation, which we call S. However, we cannot then use z alpha over 2 as a critical value because the quantity of x bar minus mu over S times the square root of the sample does not have a normal distribution. So the distribution of this quantity is called student's t-distribution. There are actually many different student t-distributions, and they are distinguished by the quantity called degrees of freedom. When using the student's t-distribution, we'll construct a confidence interval for a population mean. The number of degrees of freedom is 1 less than the sample size. 1 less than the sample size. So a student's t-distribution are symmetric and unimodal, just like the normal distribution. However, they are more spread out. And the reason is that S on average is a little bit smaller than the population standard deviation. Also, since the sample deviation S is random, whereas the population deviation is constant, replacing the population standard deviation with S increases the spread. When the number of degrees of freedom is small, the tendency tends to be more spread out and more pronounced. So here's where it's small. So we got spread out and pronounced. When the number of degrees of freedom is large, it tends to be close to the population standard deviation. We can see here where it's 10. It's pretty close to what we looked at before. So the t-distribution is very close to the normal distribution. So we have to find critical values again for a confidence interval. We're going to let 1 minus alpha be the confidence interval, and then just like before, we're going to have negative t alpha over 2 and t alpha over 2 because the area under the student's t-distribution is between these two values. And 1 minus alpha, or it is 1 minus alpha, and the critical value t a, or I keep wanting to say a, alpha over 2 can be found in this table in the row corresponding to the number of degrees of freedom and the column corresponding to the desired confidence interval. So the column gives you the desired confidence intervals, and these give you the degrees of freedom. So let's take a look. Here we have a sample size of 10 drawn from a normal population. The critical value, alpha over 2, for a 95% confidence interval. So the solution. Now the sample size n equals 10. So the number of degrees of freedom is 1 less than that. So that's n minus 1. So that's 9. Now we can consult table A3 looking to the row corresponding to the 9 degrees of freedom and the column of the confidence interval for 95%. So our T alpha over 2 value is going to be 2.262. If the desired number of degrees of freedom isn't listed in Table A, what do you mean? Well, sometimes it might be too big. Then you're going to use the next smaller number in the table. If the desired number is greater than 200, then you're going to use the Z value found in the last table, A.3 or A.2. Because remember, as we said before, then the bigger the degrees of freedom, the closer it is to that normal distribution, so the closer it's going to be to the Z values as well. So the assumptions for constructing a confidence interval for mu is when standard deviation is unknown. You have to have a simple random sample, and the sample size is large, n is greater than 30, or the population is approximately normal. So when the sample size is small, we have to check to see whether or not it is approximately normal. Now we know how to do this. The simple method can be to draw a dot plot, a box plot, and if there are no outliers and if the sample is not strongly skewed, then we've learned from previous sections that it is reasonable to assume that the population is approximately normal, and it is appropriate to construct a confidence interval using the student's t-distribution. Objective 2. We're going to construct the confidence intervals for a population mean when the population standard deviation is unknown. Looking at these tables, if the assumptions are satisfied, the confidence interval for mu when the population standard deviation is unknown using the following steps. Ready? Step 1. Compute the sample mean and the sample standard deviation if they're not given. You know how to do that. Step 2. Find the degrees of freedom, which is 1 less than the sample, and the critical value of T alpha over 2, which we have that formula. Compute the standard error, which is the sample standard deviation divided by the square root of the number in the sample. Then you're going to multiply it by the critical value to obtain the margin of error. Here you go. Going to construct the confidence interval. It's going to be x plus or minus, give or take, this margin of error, and then interpret the results. So here we have a chemist analyzing calorie content for a popular type of cookie. Please don't do that. Following are numbers of calories in a sample of 8 cookies. Find a 98% confidence interval for the mean number of calories of this type of cookie. So we're going to check, and we can see by using this simple dot plot that there's no strong skewedness, and it looks like it can be a normal distribution, so we can proceed. Now we take the sample mean and the sample standard deviation, and we calculate that by what we know how to already do, and we get those two values. So we have the sample mean, we have the sample standard deviation, and we have the n value of 8. So the degrees of freedom would be 7 because it's always 1 less than the sample. So we find that the critical value corresponding to a level 98% is 98%, 2.998. So to find our margin of error, we're going to take that 2.998 over our sample standard deviation divided by the square root of how many in our sample, which is 8, and then we get our value of 2.9947. So that is the value that we're going to add or subtract from our mean value, and then we can say that the population mean will be between 112.4 and 118.4. So we're 98% confident that the mean number of calories per cookie is between 112 and 4/10 and 118 and 4/10. Sad to say. All right, so the sample of 123 people aged 18 to 22 reported the number of hours that they spent on the internet in an average week. The sample mean was 8 hours and 20 minutes. With a sample standard deviation of, wow, 9.84 hours. Assume this is a simple random sample from the population of people aged 18 to 22 in the U.S. Construct a 95% confidence interval for the value of the population mean. The population mean number of hours a week spent on the internet by people aged 18 to 22. Now, we have a simple random sample. We know that the sample size is large, so we can proceed. We have our X bar as 8.2 and our standard deviation as 9.84, which is given to us. The degrees of freedom in the table is not there because it's 123 and we only have to 100. So we go to 100, which we're going to say, as much as I hate to say it as a mathematician, we're going to say close enough. So we're going to take 1.984. Now I take my margin of error, which is T alpha over 2 times my standard deviation divided by the square root of how many in my sample, and I'll get 1.7603. So that is my margin of error. So I'm going to take my sample mean, give or take, add or subtract 1.7603, and I will have 6.44 to 9.96. My population mean will be somewhere in between there. So we're 95% confident that the mean number of people of hours per week spent on the internet by people ages 18 to 22 years old is 6.44 and 9.96. Let's take a look at using our TI-84. Here we have the T-interval command constructing the confidence intervals when the population standard deviation is unknown. This command is accessed by pressing stat and then tests. And in the summary statistics are given, we have 8 for our T interval, and that should be selected. Now, if we have our statistics, we can hit stats. If we have our raw data, we're going to hit data. So here we have our stats, 8.2, 9.84, 123, our C level of 95. Then we're going to calculate. So a food chemist analyzed calorie content of the cookies. Here we are again. And let's take a look at this using our TI. First, we check our assumptions. We know we have a simple random sample. The sample size is small, but the population is approximately normal, as we already indicated before. So there's no evidence of strong skewness, no outliers, so we can still proceed. So this time, since we have the raw data, when we go to edit test 8, we're going to put in the data. And we have to put that data into L1. So over here, we're going to say we're putting the data in L1. Now the frequency, we're going to put the value of 1 in because we have one list there. And our confidence interval is 98%. Then we're going to calculate. And when we calculate, we will get our values of 112 and 4/10 to 118 and 4/10 rounded to the tenths place. In our sample of 123 people aged 18 to 22, looking at this, constructing a 95% interval, the mean number of hours worked, we begin by checking the assumption. We know we have an SRS. The sample size is definitely larger than 30, so our assumptions are satisfied. So we're going to go into our stats test T interval. We're going to put in our stats before, as we showed in the very couple slides ago. Then when we hit calculate, we'll see that we will get our 6.4436, 9.9564. So this was a pretty quick lesson. So from the properties, you should know how to use the student's T distribution, why we determine whether a sample comes from a population that's approximately normal or when the sample size is small, which is less than or equal to 30. And then finally, how to construct and interpret confidence intervals for a population mean when the population standard deviation is unknown. So that is all for this section, and I will see you for 8.3.